What if the deepest place on Earth is not empty, but already changing because of us? Nearly 7 miles beneath the Pacific Ocean lies a place so remote that fewer humans have visited it than have walked on the moon. The bottom of the Mariana Trench is a world of crushing pressure, permanent darkness, and temperatures hovering just above freezing. For more than a century, scientists assumed nothing could survive there. The conditions seemed too extreme for life as we know it. Yet every expedition that has descended into this abyss has revealed something unexpected: strange organisms, unfamiliar ecosystems, and eventually something far more troubling. To understand why the Mariana Trench matters, we first need to understand how such a place can exist at all, and why it continues to challenge what we think we know about life on Earth. The Mariana Trench lies in the western Pacific Ocean, east of the Philippines and south of Japan, stretching in a vast crescent nearly 2,500 kilometers long. At its deepest point, known as Challenger Deep, the seafloor falls to about 10,984 meters below the surface, a depth so extreme it reshapes how we think about the limits of our planet. If Mount Everest were placed inside this trench, its summit would still remain more than 2 kilometers underwater, swallowed by darkness. But this place is not defined by depth alone. It is the visible result of geological forces that have been quietly reshaping Earth for tens of millions of years. Here, the massive Pacific Plate moves slowly but relentlessly beneath the smaller Mariana Plate in a process called subduction. The Pacific crust in this region is ancient, formed roughly 170 million years ago when dinosaurs still dominated the continents. Over time, it cooled, thickened, and became denser than younger ocean floor. Physics leaves it only one direction to go: down. As this heavy crust sinks back into the mantle, the seafloor above it bends and fractures, creating one of the most extreme landscapes on Earth, a scar written not in rock alone, but in deep geological time. Descending into the Mariana Trench is not simply a matter of going deeper. It is a passage into a world where the normal rules that govern life at the surface begin to fail. At the bottom of Challenger Deep, pressure rises beyond 1,100 atmospheres. That translates to more than 8 tons pressing down on every square inch of space. Enough force to crush most submarines, enough to shatter unprotected bone, enough to compress the air inside human lungs until it simply disappears. This is not just depth, this is physical domination by the ocean itself. The temperature remains just above freezing, usually between 1 and 4 degrees Celsius, a cold that never changes, a cold that never leaves. Light disappears long before you ever reach the trench. At around 1,000 meters, sunlight weakens into a dim blue haze. By 3,000 meters, even that faint glow is gone. Beyond this point, there is no sunrise, no sunset, no concept of day at all. Only permanent night. The Mariana Trench lies far below even this darkness, inside a realm scientists call the Hadal Zone, named after Hades, the ancient Greek underworld. For decades, researchers assumed nothing complex could survive here. They were wrong. The first serious attempt to challenge the idea of a lifeless abyss came in January of 1960. At the height of the Cold War, when space captured the world's imagination, 2 men chose to travel in the opposite direction, down instead of up. U.S. Navy Lieutenant Don Walsh and Swiss engineer Jacques Piccard entered a steel sphere barely 2 meters wide. There was no room to stand, barely room to move, just thick metal walls between them and pressures capable of crushing battleships. Their vessel, the bathyscaphe Trieste, looked almost experimental. A massive gasoline-filled float provided buoyancy above, while the small pressure cabin hung below like a pendulum. Gasoline was chosen because it is lighter than water and resistant to compression, a strange but brilliant solution for reaching impossible depths. The technology was primitive by modern standards. Limited instruments, minimal lighting, no sophisticated imaging systems. This was exploration in its purest form. The objective was simple: get to the bottom, prove survival was possible. The descent lasted nearly 5 hours. As they dropped through the water column, sunlight faded, temperatures dropped, and the outside pressure climbed into territory no human had ever entered. Then, at roughly 9,000 meters, a violent cracking sound echoed through the hull. One of the outer viewports had partially fractured under the strain. For a brief moment, the mission stood on a knife's edge between history and disaster. They could turn back. They chose not to. When Trieste finally settled onto the floor of Challenger Deep, Walsh and Picard had barely 20 minutes to witness a place no human eyes had ever seen. Outside, their small acrylic viewport stretched a silent plain of fine, pale sediment. Their landing had stirred the seafloor into a drifting cloud, like dust floating in slow motion under artificial light. Nothing moved at first. Just stillness. Absolute stillness. Then Picard noticed a faint motion at the edge of the illuminated water, a pale shape gliding slowly across the bottom. Controlled, deliberate, alive. He later described it as something resembling a flatfish, roughly a foot long, moving with quiet confidence across the most extreme environment on Earth. Nearby, small shrimp-like creatures drifted through the beam of light, delicate and translucent. The implication was staggering. Life was not just surviving here, it was moving. But the technology of 1960 could not prove what they had seen. The submersible carried no reliable photographic systems, no biological sampling arms, no way to bring physical evidence back to the surface. When they returned and described the encounter, many scientists remained skeptical. At that pressure, vertebrate life was considered impossible. Some suggested the fish may have been an invertebrate, mistaken in poor visibility. Yet Walsh and Picard knew what they saw, and their unanswered observation would remain one of the ocean's greatest scientific questions for decades. For more than half a century after the Trieste dive, no human being returned to Challenger Deep. The risk was enormous. The cost was high. The scientific return seemed uncertain. Instead, exploration moved toward machines. Robotic landers, deep ocean probes, remotely operated vehicles lowered slowly into the abyss on miles of cable. These silent explorers began sending back the first real evidence of life in the Hadal Zone. Strange amphipods scavenging in the sediment, ghostly sea cucumbers drifting just above the bottom, microbial communities living inside the mud itself. Each mission added fragments of understanding, but something was still missing. No human perspective, no direct observation. The deepest part of our own planet remained more distant than space in terms of human presence. That changed in March of 2012. Filmmaker and explorer James Cameron, known for bringing audiences to fictional deep oceans, decided to visit the real one. Alone, inside a vertical submersible called Deep Sea Challenger, engineered specifically to survive the most extreme pressures on Earth. This was not just a symbolic dive, it was a scientific expedition. The vehicle carried high-definition 3D cameras, sediment samplers, biological collection tools, and lighting systems capable of revealing a world that had never been properly filmed. In just 2 hours and 36 minutes, Cameron descended more than 10 kilometers into total darkness, returning humanity to the deepest point on Earth. When James Cameron finally reached the seafloor of Challenger Deep, expectations were shaped by decades of speculation. Many imagined strange monsters, extreme evolution, creatures unlike anything seen before. Instead, what he found was silence. The bottom appeared vast and almost empty, a pale desert of ultrafine sediment extending beyond the reach of his lights. No towering structures, no dramatic movement, just a landscape shaped by pressure, time, and isolation. Small amphipods drifted slowly through the water column, nearly transparent, moving like particles suspended in zero gravity. Larger animals were rare, movement was rare, even sound felt absent. Cameron later described it as resembling a lunar plain. Remote, desolate, almost emotionally isolating. But the real discoveries were not visible through the window. They were hidden in the mud. Samples collected from the trench revealed dense microbial ecosystems living within the sediment itself, entire biological communities operating without sunlight, organisms surviving through chemosynthesis, extracting energy from chemical reactions between seawater and minerals deep within Earth's crust. Life powered by geology instead of light. This changed something fundamental in how scientists understood habitability. It suggested that the deepest ocean is not biologically empty. It is simply running on a different energy system. A biosphere built on chemistry instead of sunlight. In 2019, exploration of Challenger Deep entered a new phase. Not a single historic visit, not a symbolic descent, a systematic investigation. American explorer Victor Vescovo piloted a deep submergence vehicle called Limiting Factor, a titanium-hulled submersible engineered for repeat access to the deepest parts of the ocean. For the first time, the deepest point on Earth was no longer a place visited once per generation. It became a place scientists could return to, again and again. Vescovo conducted multiple dives, spending hours surveying terrain that earlier explorers could only glimpse briefly. High-resolution cameras revealed details never seen before. Sea cucumbers drifting slowly above the sediment like weightless balloons, amphipods moving with surprising speed across the seabed, delicate tracks left in the mud showing feeding patterns and migration paths. The bottom was not empty, it was active. Rock outcrops showed signs of chemical alteration. Mineral deposits formed where fluids escaped from fractures deep within the crust. Evidence that geology was still shaping the environment even here. Pressure, chemistry, biology, time, working together. The Hadal Zone was no longer viewed as an isolated wasteland. It began to look like a connected ecosystem, shaped by forces both biological and planetary. Among the most extraordinary inhabitants of the Mariana Trench is a creature that looks almost too fragile to exist there: the Mariana snailfish, a translucent vertebrate living at depths approaching 8,000 meters, making it the deepest known fish ever recorded. At first glance, it appears delicate, almost unfinished. Its body is soft, gelatinous, and lightly structured, more like living tissue suspended in water than a traditional fish. But this apparent fragility is actually a survival strategy. Rigid skeletons fail under extreme pressure. Flexibility survives. Instead of hard bone, the snailfish relies on cartilage and compressible tissues that equalize pressure rather than resist it. Instead of a gas-filled swim bladder that would collapse instantly, its body chemistry contains specialized molecules known as piezolites, compounds that protect cellular proteins from being crushed at the molecular level. Evolution here operates differently. Strength is not about hardness, it is about adaptation. Other trench species show equally remarkable solutions. Supergiant amphipods grow far larger than their shallow water relatives, possibly because extreme pressure slows metabolism and extends growth cycles. Some species chemically extract aluminum from surrounding sediments and incorporate it into protective coatings on their exoskeletons. Even single-celled life becomes monumental here. Giant xenophyophores form intricate lattice-like structures across the seabed, quietly filtering organic particles falling from the distant surface world. Life here is not just surviving pressure, it is engineered by it. Some of the most important discoveries in the Mariana Trench have come only within the last few years. In 2021, Chinese scientists operating the deep-diving submersible Fenduje, whose name translates to striver, began a series of systematic descents into the Hadal depths. This was not a single expedition, it was a sustained scientific campaign. Dozens of dives, thousands of samples, a new level of precision. Their research teams recovered extensive sediment cores from depths ranging from 6 to nearly 11 kilometers below the surface. Laboratory analysis revealed something extraordinary. more than 7,000 previously unknown microbial species, entire biological networks that had never been documented before. Many of these organisms exist in dense colonies supported not by sunlight, but by methane and chemically rich fluids leaking from fractures in the ocean floor. Around these seep zones, scientists observed structured ecosystems, tubeworm colonies rising from the sediment, dense fields of clams, thick microbial mats spreading like frost across the seafloor. Energy here does not come from the sky. It comes from the earth itself. Chemical reactions between seawater and deep crustal rock provide the fuel for life, a biological system powered by planetary chemistry. These discoveries extend far beyond oceanography. They reshape how scientists think about where life can exist. If ecosystems can thrive here, then similar environments might exist beneath the ice-covered oceans of Europa or Saturn's moon Enceladus, places where sunlight never reaches, yet life still might. Yet one of the most disturbing discoveries at Challenger Deep had nothing to do with evolution or geology. It was something far more familiar, something we recognize immediately. During Victor Vescovo's survey dives, cameras recorded an object resting quietly on the seabed nearly 11 kilometers below the surface. Not a rare organism, not an unknown mineral formation, a plastic bag. Later dives revealed additional debris, candy wrappers, synthetic fibers, fragments of a civilization that was never supposed to reach this place. What disturbed scientists even more was what they could not see with cameras. Laboratory analysis of trench organisms revealed microplastic particles embedded inside their tissues. Amphipods, worms, even microbial layers showed traces of synthetic contamination. Plastic thrown away thousands of miles away had slowly fragmented, drifted downward through the water column like artificial snow, and settled into the deepest biological systems on Earth. This changed how researchers thought about isolation. There is no true boundary between the surface world and the deep ocean. Ocean currents connect everything. Gravity connects everything. Time connects everything. The discovery carried a quiet but undeniable message. There is no place left on Earth that remains completely untouched by human activity. Not even the deepest point in the ocean. Today, the Mariana Trench represents both a scientific frontier and a warning. It shows that life can survive in environments far more extreme than anyone once imagined, adapting to darkness, cold, and pressure through remarkable biological innovations. At the same time, it demonstrates how far the influence of human civilization now extends across the planet. The trench is not a sterile abyss. It is a living world, one that carries traces of the surface world above it. And perhaps that is the most important discovery of all. The deepest place on Earth is not beyond our reach, which raises a question worth thinking about long after this video ends. If our impact can reach the bottom of the ocean, where exactly does our responsibility end? If you're drawn to the hidden worlds beneath the sea and the stories they reveal, consider subscribing to Sunken Realms Deep. Because every descent into the ocean's darkest places reminds us that the deeper we explore, the more we learn not just about the planet below us, but about ourselves.